Hey guys, hopefully this goes pretty easily and quickly. Should be just kind of a continuation on from yesterday. Let's see, a couple jokes. Let's see. What has ears but cannot hear? That would be a cornfield. Let's see. Where do sheep go on vacation? To the Bahamas. Whew. All right. Hopefully that tickled your something or other. Probably not your funny bone. Let's see. So we wanted to describe the transformations on the functions. I was going to go back to how you would have kind of presented this last year. Use the letters A, H, and K just like you would have learned last year through the multiple different times. Talk about what each of those things does. So when you see them in the problem, if you're given a function and you're asked to describe it, or if you're going to write a function based off of a description, like where those numbers go in the where the numbers go into the function, or where the numbers, like where you read them, how they come out of the function. So A is our our multiplier, and it is by far the one that people get the most confused about because it has two jobs, and so you really got to be careful about that. And so one of the jobs being that if A is greater than 1, that is going to be your stretch, your vertical stretch. And then if A is between 1 and 0, so those fractions and decimals, that's going to be your shrink. And then the other job that A has is to reflect. And so you really, if A is negative, then that's a reflection. And so where people get messed up is when they see something like -2, they think, okay, that's less than 1, so that must be some sort of shrink. Really what you got to see that is as not a -2, but a negative and a 2. So like two separate things. So this is not only a reflection, but it's also a stretch. So so just think like that. So be careful about that. It's two jobs, not one job. H, so the thing that's inside of the function, inside those parentheses, that's your shift left and right. And we got to be careful about this guy because he likes to lie to us. Okay, so we see that positive number. That's actually a left movement. We see that negative number. It's actually a right movement, and it's because why that happens is because of this negative sign that's already there. So a negative being a positive would actually be that left movement, and then a negative positive would look like a negative, and so that's actually our right movement. So. And then the K, we trust this guy. These are up and down shifts. So it's the same thing whether or not it's a cube or a square. So we have parentheses, or if it's a cube root or a square root, or we have a radical that this is A still is our stretch, shrink, and then reflection, and then H is still our left and right shifts, but lies to us, and then K is still our up and down, but we trust him. So nothing changes. Again, just like that idea that it's in H is inside the parentheses, or it's under the radical. A will always be in front of the parentheses or the radical, and K will always be after the parentheses or the radical. So try to apply that here. So here we have some descriptions. We want to write the function based off of that. So as I read through this, the squaring function is, so I want to highlight that. What function do they want me to use? All right, is vertically shrunk. So by a factor of 1/2. And then shifted down 7 units. So there's the function I need to use, and what's happening to that function. So if I just, if I thought of the parent function, that would just be f of x, and then the squaring function would just be x squared. And so then what would be this transform function, so g of x, if I want to call it that. So what we see is that we're going to do a vertical shrink, and so that's always in front of the function. So I should be thinking, that should be our a value, which should be right here. So that should go in front of the x squared. And then the next thing I have is the shift down. That's always in the k spot, those up downs. And so that's going to be after the function. So I don't need any parentheses or anything here because there's nothing inside of the parentheses. There's no left or right movements. So there's nothing inside, so I don't need them besides the x. And then my 7 units down, that's going to be a minus 7. So just going to double check, did you use the right function, squaring function? So x squared. We have our vertical shrink, which is our half. And then we have our down 7, which is our minus 7. So we've kind of hit on all the points there that they asked us to address. And looking at the next problem. So the first thing they ask us to do is the cubing function. So I'm just going to make note of which function they want. Then reflected across the x-axis. Oops. So reflection. And then shifted left 2 and up 5. So if I was just to think about my parent function, so just plain old f of x. So a cubing function would be x cubed. So I'm going to look at g of x equals. So first thing I notice is there's a reflection, and reflections always happen in the a spot in front of the function. So I put a negative there. Next thing I notice is that there is a left 2. So left 2 always happens inside the function. So now I'm going to need some parentheses. It needs to be inside the cube. So and then x, and then left 2, so that's a liar. So let's make plus 2. And I close those parentheses, and I put the cube up there. So now that plus 2 is inside the parentheses, so it's good to go. And then I have a up 5. We trust him, he's after the parentheses, after the function. So that's our plus 5. So there is our transformed graph or transformed function. And then last one, same idea. So I want to pay attention to the function, so the cube rooting function. Next thing they say is shift 3 units to the right. We got a vertical stretch by a factor of 4.5. Reflection. Ooh, we got a lot of stuff going on this one. And we've also got a shift down. So just starting off with the function, so just what would f of x be? Cube rooting, so that'd be a cube root. A lot going on here, and they actually kind of did things out of order. So if I think about what a controls, like what the thing in front of the radical would control, that's going to be my stretching, my shrinking, my reflecting. So I'm going to kind of just make note of those things first, like what things do I need to take for, what things would be in this spot here. So anything about reflections or stretches, shrink. So these pieces here need to be dealt with first. So if I have something like g of x equals, and then so I know I'm going to have this cube root of x, but in front of it I need a negative because of the reflection, and I also need a 4.5 because of the stretch. So I'm going to put a negative and a 4.5. So it'd be tricky to do it this way, again, because I may not have left myself enough space in there, so you got to kind of be careful about that. Of course, you can always just erase your function and move it if you need to. The next thing I notice is that I want to think about things that might be inside the radical. So those are my left and right pieces. So with that, I have a shift to the right 3, and then I'm going to remember that that's going to be under the radical, so I need a longer radical. And then don't trust that, so right 3 is actually a minus 3. And then the last thing that I haven't addressed yet is the shift down, which is going to be after the radical. So that should be a minus 6. That's what that function would look like. So that's as messy as we can make them. That's got everything in it. Reflection, stretch, shift left, and shift left, right, shift up and down. So that's as messy as I can make them. So if you can get that one, then you're good to go. The other ones, just have a couple things going on that kind of build in complexity. So hopefully that's not too bad. Hopefully you remember doing that quite a bit from last year, from Algebra 2. And the last thing I really want to go over today is kind of the opposite of that. So if I give you a function, writing the description, remember you only need to mention things that change. So don't mention things that don't change. Like if it doesn't move left or right, then don't say it moves left or right 0. If it doesn't stretch or shrink, then don't say like a stretch of 1 or something. That's a pretty common mistake. Like people see a function like g of x equals negative x squared plus 2, and they'll say, okay, I've got a reflection. They're like, okay, well in front of the x there's a 1, so there must be like a stretch by 1, which doesn't make sense, because if you multiply something by 1, it doesn't get any bigger. So we shouldn't mark that. And they say, okay, well, inside there's, shift right 0 units, like something like that, which, again, doesn't really make sense because we're not actually moving it. So why are you talking about it? And then that last thing they see there is the plus 2, and say, okay, now it's up 2. So don't mention things that aren't there. Don't say it's not reflected and stuff like that. Just leave it alone. If only mention the things that are changed. So let's get rid of that. So what I'm going to do is read the function. You don't need to mention which function it is or anything like that. I just want to kind of go through it and highlight the things that you see. So first thing I see is a negative. And then what I really want to do is not condense that with the 4. It's a negative and it's a 4. They're separate from each other, like I mentioned earlier. So those are 2 things there in that A spot. And then I have the plus 7. So just kind of highlighting things and saying, well, what's each one going to do? And so that negative, that's, if you want to kind of make notes, that's a reflection. The 4, that's bigger than 1, so that's a stretch. And then I'll formalize that later. And then here we have this after the square, not inside the parentheses, not inside the radical. That's more up and down, and we trust. So it'll be an up 7. So what I want you guys to do, just kind of like we talked about on Friday, was you want to say the graph or the function. So you get a choice there. I like to say the graph. Then again, I don't really care what tense you use, where you say is, was, will be. I don't care about that. And then I just kind of go in order. Is reflected over the x-axis. Then we say stretched by a factor of. So you do need to use this particular language. So we get stretched by a factor of. We say factor because factors are things that multiply. And so we're multiplying by 4 here. So stretched by a factor of 4. So it is language I will be requiring you guys to have. So by a factor of when we stretch. And then again, the last thing here, we get a choice. It's either shifted or moved. I like to use shifted, so but you need to use that one of those verbs, and then direction and distance are required. So up 7, there you go, up 7 units. So again, I'm looking for that word units there as you finish that up. So the graph is reflective of the x-axis, stretched by a factor of 4, and up 7 units. So really what I really want you guys to get with this is the idea that if I've said, hey, what's this look like? You could start to picture it, knowing that what our parent function looks like would be just a parabola, that this is going to be a reflected parabola, and it's stretched, and so that's going to be a skinnier, narrower parabola, and it also has its vertex up there at 7. So have its vertex up here at 7, and then it would be a really skinny, upside down parabola. And you start to be able to picture that in your head before you go to graph it. So, all right. So this next one, again, I just want to pay attention to what I see. So as I kind of move through the problem, so the first thing I see here is a 6 on the outside, and then on the inside I see this -3. So not too much going on here. I've got a number bigger than 1 in front, so that's a stretch. And then we've got something on the inside under the radical, so that's a left to right. We don't trust it. It says minus. It's actually going to be right 3. So again, the function or the graph is, was, will be, and then we say stretched by a factor of 6. The only thing I have to mention is the shift right. Three units. So that was pretty easy. Again, I don't say no reflection, I don't say no up and down movement, don't mention things that aren't there. And last problem, I'm going to start by highlighting things I notice. So first thing off is that minus sign, so that's going to be a reflection. Next thing I notice is the 0.25, oops. So that is less than 1, between 0 and 1. Okay, again, it's not because of the negative, it's because of the decimal, the fraction. So that's a shrink. Next thing I notice is the +2. So that's inside the function. So that is a liar. That's going to be a left 2. And then after the function, that is our one we trust. That's our up and down guy. So that's going to be a down 3. So if it helps you to make those notes, do that. Doesn't help you, then don't do it. Pretty easy. So the graph is reflected over the x-axis. Shrunk by a factor of 0.25. Oops, I didn't write. By a factor of, a factor of, and let's see, shifted and moved left 2 units, and down 3 units. Again, here, what would be after, like the ideal thing is for you guys to be able to think about what this graph is going to look like before you graph it, which, this one's pretty complex. I should have talked about this on the last one, I forgot. There is our parent function, our square root, which is our half curve to the right. So this guy is shifted left 2 and down 3. So what did it end up looking like? Left 2, down 3. So that's at my little starting point here should be shifted left 2 and down 3, so left 2, down 3, so maybe it's like about here. That's where my new starting point is. It's reflected, so instead of curving up and to the right, it's going to curve down and to the right. And then it's also shrunk, which means it's going to be flatter than the original, so it's going to be a much flatter curve. So instead of being like that, maybe it's like that. So there we are. Our new function might look something kind of like that one. So as you go to graph it, that it looks something like that. You just kind of have that picture ahead of time. I'm going to go back and talk about the other one just real quick since I forgot. I meant to do that. So here we have, let's square root again. I bet one of these was supposed to be a cube root. Let's just go ahead and change this to a cube root. Doesn't really matter. Won't affect anything that we did earlier. Just what our graph is going to look like as I go to think about it. So, cube root should be my stretched out horizontal S, right on top, left on bottom. And so what this would look like now after the transformation. So we have that shift right 3. So what's going to happen is that point that should go through 0, 0. It's now going to go through here like 0, 3, 0. So it's kind of be the middle of the. Again, that's called that point of inflection. You guys don't really know that though. And then the 6 is going to take that graph and it's going to move it up and move it down faster. So it's really be much higher than our parent function. So it would kind of much larger arc to that S is what we'd be seeing from it. So just again, they want you guys to be able to move towards that skill of being able to see the graph without actually having to graph it, or as before you graph it, so that when you do, finish your graph, you look at it and go, oh yeah, this looks right. So, all right, well, that's a pretty quick lesson today. Hopefully it went pretty well and you understand everything. But of course, you guys always hit me up if you need to. There's tutoring in the library today. There should be people there to help you. And I'll be around after school on Wednesday, not before school though. But let me know if you need to make up your test or anything like that. I'm still waiting on quite a few people to do that, so let's get moving on that. Here's your homework. Should be pretty normal things on those last 4. Kind of like I asked you to do on Friday. The book asked you to graph. I want you to just describe the transformation. So write that little sentence instead of graph it. So, enjoy the rest of your Tuesday, and I'll see you Wednesday or Thursday.